Hey everybody, Mr. Troy here. Today's video should be super quick. Just 2 examples of solving trig equations to help you make sure you know what's going on. If you are ready, it's time for Math with Mr. Troy. Okay, each example is slightly different, but they shouldn't take us that long. The first one asks us to solve over the interval from negative 5 pi to negative 3 pi, so this closed interval. We're going to start the same way we always do. We're going to isolate the variable as best we can. So we're going to subtract 3 from both sides. And we're going to divide by 4. Now, we've reached a point where we may not know what to do because we don't know the domain and range for the cosecant yet. So what we're going to do is we're going to use the reciprocal identities, and we are going to transform this into something we know. So the cosecant is the reciprocal of the sine. Then by cross multiplication, that means the sine of theta equals negative 1/2. Now there are a lot of different ways that you could have gone about and done that, but you know, that's kind of how I would look at it. This is a unit circle angle. Now, if I were to draw the unit circle, I would say, oh, the sine is negative 1/2 in the 4th quadrant at negative pi over 6, or maybe 11 pi over 6. It doesn't matter how you think about it. What's important is that there is a reference angle of pi over 6, and it's underneath the x-axis. In fact, both of these angles, so this would be 7 pi over 6. And of course, I could call it any coterminal angle I wanted. But both of those angles would solve this equation. So if I was asked for the general solution, I would say something along the lines of 7 pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n. So that's the general solution, but that's not what I'm looking for. Oh gosh, I almost forgot. N is an element of the integers. But I want to know what's going on between negative 5 pi and negative 3 pi. So let's think about that. Negative 2 pi would be 1 lap around the unit circle backwards. Negative 4 would be another whole lap. So this would be negative 5 pi, and negative 3 pi would also be there. So what angles are between negative 5 pi and negative 3 pi and have the same reference angles that I found here? Or what could I plug in for n over here to get me angles between negative 5 pi and negative 3 pi. Okay, so I cleaned that up just a little bit. If I think of this as negative 5 pi, then if I move over just by pi over 6, so negative 5 pi plus pi over 6, that would be one solution. Okay? This would be negative 4 pi. So if I did negative 4 pi minus pi over 6, that would be another solution. But of course, I would want to give those as proper or improper fractions with the like terms combined, let's say. So if I were to convert those would be negative 29 pi over 6 and negative 25 pi over 6. If you're more of a visual person, then think about it as if it were on the unit circle. Draw some reference triangles, show your reference angles in there. If you're not that sort of visual person, and that's okay, then think about plugging in different values for n until you get things that are between negative 5 pi and negative 3 pi. I want you to stop and think about how I knew that that was a unit circle problem once I got to, say, those steps. Okay, pause the video, have a think, we'll come back to that later. Okay, so here's our next problem. Let's go ahead and try and solve this. We're going to subtract 5 from both sides. And we're going to get 2 sine theta equals negative 11.5. We're going to divide by 2. And this is the sort of process that we're going to go through all the time. And we're going to get this sine theta equals negative 5.75. Now, a lot of people will know immediately that this is no solutions. Now, how could we know that? Well, if we put the sine inverse of negative 5.75 into our calculator, we're going to get a domain error. And that's because the sine inverse can only have plugged in things between negative 1 and positive 1. This is actually a range error. The range of the sine function we learned yesterday is only between negative 1 and positive 1, so this would be no solutions. Okay, I think let's look at one more. I'll give you one to think about, and then we can talk about it in class tomorrow. Okay, so this is almost exactly the same problem, except it is going to have solutions. I changed the sign from a plus to a minus. Okay, a couple of things to note before you do this problem. You are going to have to use degrees because of the way the problem prompts you. And this particular one isn't going to work out to a nice number, so you're going to have to use a calculator. Okay? Give that one a try. We will check up on that tomorrow. And in the meantime, you can listen to the quadratic formula song, because why not? X equals opposite b plus or minus the square root of b squared minus 4ac all over.